the training process. We'll start by loading TensorBoard, then we import the date time, which we shall see shortly why we need this. Run again. Now TensorBoard being a callback, we define it as simple as this. Just like the other callbacks, we have tf.char as the callbacks, and then we specify the TensorBoard callback while specifying the log directory. Now the reason why we have this log directory is because for all the information or all the training and validation information we shall be visualizing in TensorBoard, they need to be logged somewhere for TensorBoard to show them as a visualization. So that's why we have this log directory here, which is defined. Now this log directory, we've defined it previously. This log directory right here, you see this log directory right here, is the ImageNet logs scalar. So basically this is, we could take the directory to be simply this, and here is it. We have ImageNet logs, then scalars. But then supposing we train our model the first time, then we'll train it again the second time, and then we'll train it the third time and many other times. We want to have different logs for all the different training processes. So that's why instead of just creating this one directory such that after training the first time, this logs come and say crush or replace all the previous logs, what we do is we include a timestamp such that inside this directory there is a name given or a directory created such that its name depends on the current time, as you could see right here. And basically what that does is we have logs for different training processes. So let's take this off. Then also note that by default the data which is inputted in the logs, that is if we set the log directory like this, and then we have our callback, that's a TensorBoard callback, the information we shall be passing in is this loss and then all the metrics we shall have here. But then if we want to include some other information in the logs, like for example the learning rate, like in this case where we have this learning rate scheduler which modifies the learning rate as we keep training, and maybe we want to visualize the learning rate or the current learning rate during the training process, we could use this TensorFlow summary.scalar, which takes in the name, it takes in the data, in this case is the learning rate, and then we specify that we are going to be logging this information after every epoch. So basically that's it. And once we do this, we also need to define this file writer, and the way we define it is by using TensorFlow summary.createFileWriter, which takes in this log directory, and then we create another directory which we shall call params. And once we have this, we set this as default. So once this is done, we could load this, run that, run it, and recall that we need to always set this for each of the parameters we want to be working with. So run that, run this, run that. We compile the model and then we train. Now before training, let's increase this to 30 epochs. Now we shall use a smaller part of our training set. So let's take this off. This is a smaller part of our training set. Then we include the TensorBoard callback right here. That will start training. As we go on with training, the loss decreases while the accuracy increases, and then we get to the final training step or the last epoch. Now let's go ahead with the TensorBoard visualization. To visualize all the parameters and the metrics, what we'll simply do is call this TensorBoard, then we'll specify the logdir argument. And once we specify this argument, now depending on where we've stored these different files here, those different logs, our case is this, so this is the main folder. We now have to pass it in here as a parameter. But before running that cell, let's get to understand what's going on. What happens is while the training was going on, we had this, as you could see, ImageNet logs, scalars, and then this file name which we had defined previously with the date, the current date time. So we've used this current date time to create a folder, and in that folder the parameters start. Now this parameter in our case is just the learning rate, as this was the only scalar we passed in. And then for the train, we see we have this train and validation folder. Now these two folders come up because we are storing the loss and the metrics values. So as you can see right here, we have the logs for the loss and metrics value, both for the training and then for the validation, while this is to store any scalars, in our case the learning rate. And that said, we could now run. There we go. First of all, we notice that we have several of these lines. Now these were previous runs, so this were previous times when we did training. Let's toggle all those runs and then select just the last run. Now this here's the last, this one and this. Okay, so if we select just this, you notice that the learning rate as we defined is initially this value constant, and then it increases, or better still slowly increases up to this point right here. So there we go, we have our learning rate which we could monitor. Then we have the epoch loss. Now this epoch loss is for all this. So let's take this off. If we take off the parameters, now if we take off the parameters, you notice that we have nothing for the learning rate, because basically you see this is the file name, and then you specify params for the scalar, which is the learning rate. So if we take this off, you see nothing comes up. See that comes up. If we get this, you see this was for another training process, so let's take that off. Now if we focus just on this, you see we can have that. Then let's take off the validation. Now we focus on the epoch loss for just the training, and there we go. You see how this loss drops. Take this off. For the validation, you see takes this value. Now we could compare the loss values for both the validation and the training. So this is a very easy way to look at that. Then we go ahead to look at the accuracy. See here how the accuracy increases up to a value of 1. See, increases up to a value of 1. But this is normal because we're overfitting on a very small part of the data set. Then if we take off the training, you see the accuracy. So that's it. Basically, we could take this off again and then view the loss. And there we go. We are able to use TensorBoard in our browser to visualize what's going on during our training process. We could always increase, reduce. See, that's it. Now we could also smoothen. So let's take the params right here. Let's take this, smoothen this. Anyway, that's it. We've seen how to log data into TensorBoard and also how to visualize this data. Another very interesting part of TensorBoard, which I'll be looking at, is the graphs. So if we get to the graph, you see the graph is going to be generated right here. Let's go up a little bit. Okay, it's loaded. Now that the graph is loaded, you see it reduces. You click on it and then you see reduce, or you could increase. You could drag. So depending on how you want it to be, you could look at that. Let's get to zoom in. Could pull this way. Zoom in like this. It's quite easy. There we go. Now let's look at each part of this graph. We see here that we have this rescaling, which gets into the sequential model. Now we've seen this already, but before we get into this, notice that there is a legend right here. This legend tells us the significance of the colors is same substructure. That's why you see the rescaling. See, they have the same color. Let's drag this, take this downward, take this downward again. Let's look at this two right here. They have the same color, the same structure. Now the rectangle with a circular around that edge is a unique substructure and also expandable. So you'll see that some of those structures or substructures are expandable. Like this, for example, you see a little plus up here, which when you click, you could see its inputs and then its outputs. Let's double click on this, and there you go, it expands. Let's put it this way. As you could see, we have those inputs, then we have the random flip, which we defined already. We have the random rotation, we have the saturation layer. Could double click on this. Recall that the random flip was both horizontal and vertical. So as you could see here, we have random flip left, random flip up. If you could look at this again, click on this. Let's double click. Oh, that's moved. Double click. Let's pull this upward, and you can see exactly what's going on in the random flip up down. As this graph right here basically shows us all the different operation which goes on in the random flip up down. Take this out. Let's reduce and drag it again. So after this, now we get into this conf1 pad right here. Notice that we have this conf1 pad, which comes as a first layer after the input layer in the mobile net version 2. So if we scroll down back, notice that we have the conf1 pad, we have conf1. Go back up. Let's look at this. There's it. So basically what we're doing here is this graph is showing us detailing all the constituents of the model, which is represented in the graph form. Now coming back to this, we have namespaces, up nodes, unconnected series, connected series, TensorFlow constants, summary, data flow edge, and then control dependency edge. So that's it for the legends, and then this final reference edge here. So here we get back to our graph. We have the conf1, which is the start of the mobile net. Notice that there is this link to the mobile net version 2 for all these layers which are part of the mobile net version 2 here. We could go upward. There we go. We see all those links to the mobile net version 2. And also what this is showing us is that we could get from this inputs and go through the full mobile net. So this is kind of like the mobile net we saw on the paper, which is now shown graphically without having to redraw it, and this is kind of like done automatically since TensorFlow creates this graph before training. Scroll up. See, these are the different layers which make up the whole graph or the whole model. Up to this last layer here where we have this output ReLU. Then for the dense layers, they're represented right here. We have this mobile net input, we have the global average pooling, then the dense layer, or the first dense layer, and then the second dense layer. Actually this is meant to be one, but there's an error which was made here. It was this what we had previously. We doubled this by error, so if we take this off, we just have one dense layer. Anyway, normally this should be just one, so that's it. If you open up one of this, double click, let's pull this, let's double click this one. Okay, now let's drag this, and then you see clearly that once you have an input, there is this matrix multiplication, and then there is this addition. This matrix multiplication, you can double click again. Let's double click on that. Let's pull this way. Okay, so here we have this matrix multiplication, which takes in this weight, which you call the read variable up, and then it also takes in the input x. So if we have the weight and we have the input, we go through this matrix multiplication, and then we have this output right here. Then after getting this output, we have the addition with the bias. So obviously here we're gonna have the input plus, so you see that you have an addition here. Again, we have the bias, which is actually a weight. So we have the input from the matrix multiplication plus this bias, and then we have this output right here. Then after this we have the softmax. So basically that's it. Once we have the softmax, now we get into this other dense layer. But yeah, we have these two dense layers simply because there was that error which was made here. Nonetheless, if you take that off, we will just have one. So you end up with a softmax layer right here. And this shows us exactly how to visualize a graph which has been generated by TensorFlow on TensorBoard.